children. Welcome to our online chemistry class. So last class we discussed about the history of periodic table, isn't it? So today's class we are going to discuss about the modern periodic table. So let's see what are the features of modern periodic table. Here you can see the modern periodic table. It is invented by the scientist mostly. Now also we are using the same periodic table. Here you can see the elements are arranged in the increasing order of atomic number. Here you can see hydrogen 1, helium 2, 3, 4. So there is a periodic law. According to mostly, the periodic law is the elements are arranged in the increasing order of its atomic number. So after a regular interval, the elements are showing the same properties. For example, if we check these elements, lithium, sodium, potassium, rubidium, cesium, francium. If we check this one, lithium, sodium, potassium, rubidium, cesium, francium, almost having the same properties. So after a regular interval, they are showing a repeating nature. This is periodic law. Okay. So let's see the features of modern periodic table. So elements are arranged in the increasing order of atomic number. And here you can see some columns, some rows, etc. So these vertical columns, for example, these vertical columns are known as groups. So can you find out how many groups are there in a periodic table? So there are 18 groups are in a periodic table. Then the horizontal rows. Here you can see the horizontal rows. Here you can see horizontal rows. These horizontal rows are known as periods. These horizontal rows are known as periods. And how many periods can you identify? There are 7 periods in the periodic table. 7. Here you can see those. First period, second period, third period, 7 periods are there. And the first period, which contain hydrogen and helium, it is the shortest period. Okay. And here you can see a separate group, isn't it? So one of the demerit of Mendeleev's periodic table is he couldn't give a proper place for lanthanides and actinides. So what are lanthanides and actinides? I hope all of you know what are lanthanides, actinides, all those things. Lanthanides are the elements come after the element lanthanum. And actinides are the elements which come after the element actinum. So I hope all of you know this. So mostly could give a proper place for a separate place for lanthanides and actinides. Okay, and if we check this periodic table, the first group of elements are known as alkali metals. The second group of elements are known as alkaline earth metals, and third group, these 3 to 13 groups are known as transition elements, and these elements are known as representative elements. Okay, 13 to 18 together they are known as representative elements. First and second and 13 to 18 are known as representative elements, and each groups are known by the name of the first element. For example, this group, the 13th group is known as boron family, 14th group is known as carbon family, 15th group is known as nitrogen family, and 16th group is known as oxygen family. And these oxygen family elements are also known as chalcogens. So you have to find out why they are known as chalcogens. And the 17th group elements are known as halogens. Halogen means, the halo means easily leaving. If we take a reaction, if the element is contain halogens, for example chlorine, fluorine, bromine, iodine, etc., they are easily leaving. In a reaction, these elements are easily leaving. Okay, so that's why halo means leaving. So this 17th group are known as halogens, and then the 18th group are known as noble gases. Why they are known as noble gases or inert gases? Because their outermost shell contain 8 electrons. So as by octet rule, they are highly stable. So they need not to take electrons from any other element. So they are noble. So they are known as noble gases. Okay, I hope all of you understood what are the features. And how to write the if in future we may find more elements, isn't it? So now there are 118 elements, maybe it will be 120,000, we don't know. So the technology is increasing day by day, isn't it? So how can you write the names of the elements more than atomic number 100? Here you can see some UUO, UUS. What is this UUU or UUS? What is this UU and all those things? It is the symbol of those elements. It is we can write the name of those elements by certain rules. It is according to certain number. So for each number there are certain root words. It is by the Latin or Greek words. For 0 nil, for 1 see, you can see here. So let's see how to write the name of the elements more than the atomic number 100. So let's see how to write the name of the elements more than atomic number 100. Okay. So you can see here, as we discussed earlier, there are some root words for each number. For 1 un, for 2 by, for 3 try, etc. And symbols also here, UB, like that you can see. So let's see with an example. Okay. So it is according to the atomic numbers, isn't it? So the first number is 1. So we have to write the root name of the first letter. So it is an. So we can write here an. And we have to check which is the second number. Second number is 0. The root word is nil. So un, nil. It is the last letter 1. So again un. Un, nil, n. So in the end we have to add ium as the suffix. So un-nil anium. So its name will be un-nil anium. Then let's check with this one. How can you write the name of this element having number 122? How can we write? Here again 1. For 1 we know that an. For 2 by. So again 2 by is here. If it is ending with the letter I, we need not to write the IUM. For example, if we write here and by here, we need to write only UM. No need to write IUM. So already I is here, so we can make it shorter. So and by BM. And how can you write the symbol for this? So we have to take the first letter of each root word. For example, 1 and so the first letter U, and second one nil, the first letter N, then 1 and so U N U. It will be the symbol. For writing symbol, we have to remember that the first letter should be in capital. The next letters are in small letter. Here, how can you write the symbol? U by B, again by, so UBB. Symbol will be UBB. I hope all of you understood this. So, how can you write the electronic configuration of an element? What do you mean by electronic configuration? Electronic configuration is the systematic arrangement of electrons in each orbitals. Okay, I hope all of you know what are the quantum numbers, principal quantum number, azimuthal quantum number and spin quantum number and all. There are 4 quantum numbers. If we want to know the exact position of an electron, we need these 4 quantum numbers. Okay. So let's see how to write the electronic configuration. So we know the orbital name. The first quantum number, principal quantum number denoting the main energy level. The second quantum number is denoting the orbital name. So there are 4 orbitals S, P, D, F and I hope all of you know that. So there is a method to write the electronic configuration. First we have to fill in the 1s, then 2s. There are certain rules for that, of principle and all. In second chapters we already studied this. So 1s, 2s, here you can see, then 2p, then only 3s. Here you can see 3p. So there is a method. Okay. So how to write the electronic configuration? So S subshell, it can contain 2 electrons, and maximum number of electrons which can contain in S is 2, for P 6, for D 10, for F 14. It is by the equation 2n square. Okay. So what will be the electronic configuration of the hydrogen? Hydrogen having the atom number 1. So the only 1 electron is, so it is first filled in where 1s, isn't it? So 1s1, it will be 1s1 for helium. 2 electrons are there. So it will be again 1s2. So S can maximum 2 electrons, isn't it? So it is in the first period. So the 1. That is the 1. First period 1. Second period, if you check the other element hydrogen, helium, lithium. Lithium is in second period. So it will start with 1s1, 1s1, sorry, 1s2, 2s1, 1s2, 2s1. It will be goes like that. I hope all of you studied this. So what will be the atomic number of potassium is 19. So what will be the configuration of potassium? Let's see. Its main electronic configuration is, according to the main energy level, it is atomic number is 19. So 2881, isn't it? So what will be the subshell configuration? So 19 elements are there. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So if we see this configuration, you can find out where will be the electron. How can you find out that? Let's see. Here the rule is here. We have to find which is the most occupied energy level. Here you can see 4. So this element will be in the fourth period. This element will be in the fourth period. Let's check with this one. You can see 1, 2, 3, 4. Yes, potassium is in the fourth period. So if you see an electronic configuration of any element, you can find out where this element will belongs to. Okay. So it is the method. So 4. It is 4. So it will be in the fourth period. And where the last electron is entering, that will be its block. Here it is in S, isn't it? Last electron is entering to the S. So it will be in the S block. It will definitely in the S block. You can see here. As here you can see potassium in the S block. The first two blocks are known as S block. This is P block, because the last electron is entering to the P shell, and this is, if the last electron is entering to the D shell, they will be in the D block, and if the last electron is entering to the F shell, so they will be in the F block. According to that, we can classify the periodic table as 4 blocks: S block, P block, D block, F block. S, P, D, F. Okay. So if the last electron is entering into the S subshell, it will be in S. If it is P, it will be in P. If it is D, it will be in D. If it is F, it is in F block. So let's check this table. What can you understand from this table? Here, the valence shell configuration is here, isn't it? Main electronic configuration is, that is n quantum number, that is principal quantum number, and configuration is there. Valence shell configuration, that is the last shell configuration. If we check with lithium, it is 2, 1. So 1s2, 2s1, 1s2, 2s1. Similarly, you can see here, for each element, the last electron is entering into the S shell. So I already said, according to that, we can classify them as X block elements. And if you check here, these all elements, the first group elements. So how can we classify the elements in a group? It is the basis of the elements in a group. If you check their valence electronic configuration, that will be same. If certain elements having the valential electronic configuration as same, they will be in one group. So if we check in a group, all elements having the valential electronic configuration will be the same. The valential electronic configuration is same. For example, you can see S1, 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 S1. So these all elements having the same property, because the valential electronic number is the same. So they will be in first one group. So it is the property of elements in a group. So what will be in period? Let's check with period. This is fourth period elements. Here you can see the configuration. Here you check all last element is entered to, sorry, which is the highest principal contact number here, which is the highest number here. Here if we check all element, calcium, potassium, scandium, titanium, vanadium, chromium, manganese, if you check here you can see here calcium, potassium, calcium, they are fourth group, fourth period elements, isn't it? So if you check here, the last electron entered to the fourth main shell or fourth subshell, isn't it? Fourth shell. So they are in the fourth period. So if we check a period, the main energy level, it will be the highest number. So if we check every element, the last electron entered to the if it is 4, it will be in fourth period. If it is 5, it will be in the fifth period. If we check a period, we can see which will be the highest quantum number, highest principal quantum number is here, that will be its period. So if we check a period, all elements having the last electron enter into the same principal quantum number, that is n, that is this 4. Okay, I hope all of you understood this. So what we learned how can we what are the features of modern periodic table, and the electronic configuration group, electronic configuration the period, and how to write the element's name after 100th element. Okay, I hope all of you understood. If you have any doubts, we can clarify in your life, we can clarify, you can ask. Okay, thank you.